Hi, my name is Shipra and I'm going to talk about the topic mutual exclusion. And for this, I read this paper that shows an optimal algorithm for mutual exclusion. Now, let's first talk about what mutual exclusion is. As we have multiple processes that tries to access the resource at the same time, so what happens is we can have the data inconsistencies and there would be multiple processes in the critical section at the same time. So in order to avoid those conflicts, we have these algorithms. Now, there are different categories of the algorithms that are token-based solutions and permission-based solutions. Now, in token-based solution, we have one particular token in the entire network, and only the process with the token will be able to access the resource. So this actually ensures mutual exclusion because the process with the token will be able to access the resource. So that's how there will be only one process in the critical section at a time. Now, this solution has the properties that it avoids starvation and it avoids deadlocks because it allows just one process to access the resource at a time. But this solution has the drawback also, like if the token is lost, then the entire network will be down as we are relying only on the token for this algorithm. Next solution is the permission-based solution. So in this, the process that wants to access the resource will need to grant the permission from other processes in the network. And we have different algorithms for this that are a centralized algorithm and a distributed algorithm. In case of centralized algorithm, as you can see in the diagram, in figure A, we have three processes P0, P1 and P2, and there is one coordinator, that is C. So if process P1 wants to access the resource, let's say X, so it will send the request message to coordinator, and then coordinator will see if the resource is available for P1 to access. It will send the grant message or the OK message to P1, and then in the figure B, the process P2 also wants to access the same resource, so it will send the request message to the coordinator. But now at this point of time, coordinator knows that the resource is not available as it is being accessed by P1, so coordinator will not send any reply to P2, and instead it will put P2 into the waiting queue. After that, in figure C, after process P1 is done accessing the resource, it will send the release message to the coordinator, and after that coordinator will see now the resource is available, so it will send OK message to P2 and remove P2 from the queue. So that's how this algorithm works. But now this algorithm has various advantages and disadvantages. The advantages are that it avoids the problem of starvation and deadlock. Again, like it just allow one process to access the resource at a time, and it guarantees mutual exclusion. Now this algorithm is easy to implement as we have just three messages in this algorithm, that is request message, OK message and release message. But now the disadvantage is we have the single point of failure as we have just the coordinator who is actually controlling the entire network. So if this fails, then the entire network will be down. Now this is the another algorithm, that is distributed algorithm, and paper actually talks about this algorithm. So this algorithm is based on the priority, like whatever process comes first will be able to access the resource first. So in this case, the priority is decided on the basis of the timestamp. So whenever the process wants to access the resource, it will send a message to the other resources with the resource name, process ID and the current logical time. And the process who will receive the message can take three actions. That will be either the receiver can send OK message, or it will not reply. And if the sender as well as the receiver wants to access the resource, so there will be conflict there, and in order to avoid the conflict, timestamp of both will be compared and the lowest one wins. Now in this diagram, as you can see, we have three processes, 0, 1 and 2. Let's say 0 wants to access the resource X, so it will send the request message to 1 and 2 process with timestamp 8, then process 2 also wants to access the same resource, then it will send the request message to 1 and 0 with timestamp 12. And then as process 1 doesn't want to access any resource, so it will send okay, that is the grant message to 0 and 2. But now here is a conflict that 0 and 2 both processes want to access the resource. So in order to avoid the conflict, as I mentioned, the process with the lowest timestamp will win, so 0 will get to access the resource. And once 0 is done accessing the resource, it will send the okay message to this process 2. Now, this algorithm has advantages that it guarantees mutual exclusion, that is, only one process will be accessing the resource at a time, and it avoids these starvation and deadlock problems. Now, the paper says that it is a very optimal algorithm, as we will be having just n minus of 1 send and receive messages, so there will be in total 2 into n minus of 1 total messages in this algorithm. So that is why it is an optimal algorithm. Now again, this also has advantages like endpoints of failure, and it has to maintain the membership list, but it is always better than the centralized algorithm. And these are some of the references, and thank you.